Before we start the session, I would like to remind two things, just two things. For those who attend this meeting in person, in case of emergency, please follow the instruction from the Congress Center. And for those attending this, for all the online participants, because of the copyright regulation, please refrain from recording or taking screenshot of the meeting video during this session. Thank you for your cooperation. So now it's time for the session. Good morning and good afternoon and probably good night. I am Nonaka Hidehiko. I'm serving on the moderator of this session. So welcome to the Tsukuba Conference session. And let me introduce briefly about this session. The Tsukuba Conference session is, of course, named after Tsukuba Conference. So let me explain briefly what the Tsukuba Conference is. The Tsukuba Conference is an international meeting for young researchers all over the world from different various fields and with various backgrounds to discuss global issues. And I think the young Davos would best explain the Tsukuba Conference. So the first conference was held in 2019, and it's to be held every 2 years, alternatively with this TGSW. Although the impact of COVID-19 changed a little bit to this convention. So in this Tsukuba Conference session, we're going to discuss what we can do for realizing a decarbonized society. And this topic will be one of the important issues to be discussed in the Tsukuba Conference 2023. So we hope that we have very nice, active discussions on these topics. For this session, we have invited 6 leading researchers from the research institute located in Tsukuba Science City. And in the first part, we'd like to ask the presenters to, in order to learn the basic idea of each research center, research institute, I'd like to ask the presenter to introduce the initiatives taken by each institution. And then after a break, in the second part, we're going to have panel discussion with the panel discussion. The presenters will be the panelists now. And because the institution has very different background and research targets, I think there will be a discussion or there will be comments and proposals from different view from each institutions. So now let me briefly introduce the presenters here. From this side, Dr. Kimura Masao from High Energy Accelerator Research Organization. And then Dr. Shakti PC, National Research Institute for Earth Science and Disaster Resilience. And Dr. Kondo Takahiro from the University of Tsukuba. And Dr. Tai Yutaka from National Institute of Advanced Industrial and Science Technology. And Dr. Tsuchimoto Takahiro from Building Research Institute. And Dr. Ashina Shuichi from National Institute for Environmental Studies. Thank you. So now we want to start the first part. So could Dr. Kimura start your presentation here? Thank you.
Okay, good afternoon. My name is Masao Kimura. I'm working for Institute of Materials Structure Science in High Energy Accelerator Research Organization, so-called KEK. At first, I would like to thank for the organizer to give me a chance to join this very interesting meeting. Our organization are specialized to design, build, and utilize a big accelerator facility like this. And in our institute, we use 4 types of quantum beams. That is synchrotron radiation, X-ray, neutron, positron, and muon. We use these beams for characterized materials and protein and try to understand the reaction mechanism. Okay, so today's topics are decarbonized society. What we can do for that? The mountain of decarbonization is quite high and big. So today I would like to emphasize 2 points. The first, there are no shortcuts nor magic. Our route seems to be very short, but it must be steep. Another route seems to be very short and seems to be very gentle. It must be long. And we have to climb up to the top of this mountain, not by ourselves, but together. So routes must be determined in terms of various aspects, such as scientific principle, society, economics, politics. So today I just would like to comment some points in terms of scientific principle, in terms of material science. Okay, so why we use the reaction of carbon combustion? Yes, the answer is very simple. We can get a great energy. If we burn 1 mole of coal, we can get about 94 kilocalorie. It's 2 times of hydrogen combustion. And compared to the human activities, it's as high as 1/30 of calorie required for human body per day. Yes, carbon dioxide is very stable. So in other words, if we try to change carbon dioxide into another compound, we need a lot of energies. So we have to use the energy that has not been used. Otherwise, the approach is meaningless. So what can we do that? Of course, the nature knows the magic approach. It's a photosynthesis. Green plants use sun energy and change carbon dioxide into oxygen and sugar. So we try to mimic these processes using such as various catalysts. In the reactions, the most important and difficult reaction is the last one, the reduction of carbon dioxide into carbon monoxide. When we use a synchrotron radiation, we can see the change of atomic structure that occurs in a very short time. And we can understand the mechanism and try to use this reaction to reduce the carbon dioxide. But magic is a magic, so it's very difficult. During the meantime, we also need more realistic approach. So why don't you go back to the data? It's the emission, carbon dioxide emission by sectors. The top or worst three is energy conversion, industry, transportation. So what can we do that? The answer is always simple. Making reactions more efficient. When we try to shift from thermal energy into the wind and solar energy, we need a storage of energy, that is battery. So the efficiency of solar panel and battery is very important. Industry, they use many types of reactions, so the efficiency of those reactions are very important, of course. Transportation. Yes, the fuel efficiency is very important. If we can find a new material that is very high, very light and strong, the efficiency must increase rapidly, and that reduces carbon dioxide. So I just showed the example of the battery. As you know, the battery has a hierarchical structures in multi-scales of space and time. So in order to improve the efficiency of batteries, we have to understand the reactions in multi-scales. This is just a picture of the cathode D electrode of lithium-ion batteries. And when we use synchrotron radiation, we can see the change of atomic structure and mapping the locations. So this shows the location of the lithium. Red shows the lithium high position. And during the charging, lithium get out of the oxide. And during the discharging, they go back to the oxide. But you see, this is not heterogeneous, homogeneous, but heterogeneous. Yes, some grain do not work. And you see, this is a start, E is the end, but it is not exact. Yes, they do not return to the initial state during a cycle. This phenomenon is called degradation. When you buy a new iPhone, you can use for a few days, but after a few years, you have to charge telephone every night. So if we understand the gradation mechanism, we can improve the efficiency a lot. Okay, I just showed example, magic or improvement efficiency routes. But as I said, approach must be determined in terms of various aspects. So I just mentioned in terms of material science, but today there are a lot of experts in many fields. So I'm very looking forward to share the opinion and discuss the very difficult topic. Thank you for your attention.
Thank you very much, Dr. Kimura. And I would like to invite Dr. Shakti for next talk.
So thank you, Professor Nonaka. for coordinating and organizing these sessions. It's my very pleasure to be a part of this conference. Okay, my name is Sakti PC from NID, and for your information, NID promotes diverse research with the basic objectives of realizing resilient society to natural disaster by enhancing science and technology for disaster risk reductions. So that's why there are several research divisions in NID. So one of them is Storm, Flood, and Landslide Research Division, where I belong. And in these divisions, the research on predictions of complex water-related disaster is the main objectives. This division also working on the implementations of the developed technology in the society. Therefore, today I'm going to talk on the topics enhancing flood resilience and adaptations for future climate change. So every year, hundreds of thousands of peoples worldwide are affected by natural disasters. So among them, water-related disasters such as flooding is one of the most common. So for example, we can see in this image, based on the 2001 to 2020, so that image prepared from the UNDRR. So you can see the more than 82 million people are affected by flooding. So which is the most highest among other natural disasters. So on the other hand, so this animations shows the flooded river basins from 2010 to 2021 in Japan. It is clearly seen that the extreme rain events and associated floods have been frequently experienced in several prefectures in Japan. So, this is the situations in Japan. That's why the annual cost, damage annual cost are also increasing if we look in this figure. So recently this trend is increasing much than previous one. Hence, based on the trend of such events, it appears that the flood disaster caused by extreme rainfall may occur in coming years. And moreover, based on the projections of the climate change for a varying scenario and simulations, there is a possibility that the frequency of flood event will increase in coming years. So in this changing environment, the comprehensive disaster risk assessment would be the fundamental steps towards the decarbonized society. That's what we believe. So at this stage, we are doing different components. So the first one is the intense observations. So the NID deployed X-band multi-parameter radars at first and succeed in a real-time monitoring of heavy rainfalls and developed as an operational basis all over Japan. So then after that, the next step is very important steps is the hydrological analysis. So which is the key part before going to the next steps. And in this case, the parameters such as social informations, of course, hydrological simulations. So all can be combined together to analyze this kind of, like for example, flood inundations mapping in a real-time basis. So after that, combining all these social informations data and with flood inundations mapping, including the future climate scenario, we can deliver the varieties of the risk assessment based on our priorities. So this is the overall flow for the towards the decarbonized society. And among them, we are working on some component. In today, I'm going to talk about, as an example, so the quick exposure assessment of flood inundations, a case study of Hitoyoshi City in Kumamoto Prefecture, Japan. So in the first week of July 2020, the torrential rainfall caused heavy flooding in Kyushu region. So among them, the Hitoyoshi city in Kumamoto Prefecture was severely flooded, especially northern part of the Hitoyoshi city. You can see the damage of bridge and some other situations here. So in this case, we first developed the flood inundations map. So recently the user and the social media users are increasing rapidly. So we can collect this kind of flood mark within the social network systems. So using that information, we can immediately develop the flood inundations map within the flooded area. So here also we did the same approaches, and later on we also compared with the observed flood marks, and the relationship between observed and estimation is very good. So once we develop this one, then we can do something for the exposure assessment. So for the exposure assessment, we combine flood inundations map with the social information such as land use, roads, buildings, and population, etc. So combining them, we can it's a very easy to deliver, display the status of social information in GIS format during the flood events. So what we believe is that releasing such exposure assessment of flood inundation in real time can be useful for different, like for example, implementing a quick strategy and special actions to collect damage information. Similarly, emergency response, evacuation, and smooth recovery, and as well as it will be very important for the local and national governments. So this one is, this image is one of the example of the exposure assessment. So this is the scenario of the building during the flood event. So we can see, so how many buildings are in the danger zone, or how many buildings are in the safe, or so we can clearly display this kind of scenario in real-time systems. Similarly, another important things is of course, the road networks, because during the flood events, so many people go out from the disaster, want to go out from the disaster area, and many vehicles also want to enter the disaster area for the support. So it's very essential to display the scenario, road network scenario. So this one is one of the example showing the scenario of the road networks. So similarly, we can see many other parameters. So this is one just the example. And we also check our this system works very well or not. So this is one of the validations. So in the flooded area. So this is a kind of validations. So this is the summary of my presentations. Of course, I already mentioned in the earlier presentations that I and my team at Storm Flood and Landslide Divisions are working on several components for enhancing flood resilience and adaptations at this stage. So our basic steps are, of course, the collections of relevant historical data, and of course, the regular monitoring of observations data, and the research towards the development of new data sets. So particularly, I have been working on several projects. So for example, quick estimations of flood inundations risk in river basins in Japan, and the development of river geometry, and similarly the predictions of river discharge using seismological noise data, and also the hydrological risks on localized area. And of course, we are very interested to consider about the future climate change in our workflow. So And we are also interested in the comprehensive risk assessment focusing on near real-time basis. And of course, we are also interested in digital twins for improving flood resilience. And which is very, of course, the last one, but it's very important, is research collaborations between university, research institute, or some company. Are also one of the priority. So this is all my presentations. Thank you very much for listening.
Thank you very much, Dr. Shakti. So now move on to the talk by Dr. Kondo Takahiro. Dr. Kondo, please.
Thank you for introduction. I'm now director of the R&D Center for Zero CO2 Emission with Functional Materials. And today we are, this center is just started from this April. So I would like to introduce our center and our seeds for materials contributing to the decarbonized society. So this carbon neutrality, if we want to realize carbon neutrality, but to do so, we need to develop many technologies. Our R&D center focused on two important technologies. One is the utilization of hydrogen as fuels. As you know, hydrogen can react with oxygen to form water. Meanwhile, we can get energy, and we don't emit CO2. This is very good news. So if we can replace all automobile or vehicle by this energies, we may not produce CO2 from such vehicles. So we can maybe reduce CO2. Also, the other one is a conversion of CO2 to useful chemicals. This is examples of the methanol synthesis. If we can make methanol, we can use this methanol as a material for the chemicals. Now we use oil to make the chemicals, but we can use methanol to make chemicals. So we can reduce many CO2. Besides, this directly converts CO2 to methanol. So this is reducing minus CO2 technology. So we are now very focusing on these two important technology. And to tackle with these issues, the young generations, young professors of 20s to 40s gathered as the R&D center. They are the experts of the materials and materials analysis. Of course, we have the great senior advisors in the university. They are very famous in the world. So advisors are always advise us. But the main characters are these young generations. And these are the experts of the analysis of material and experts of the material development, material design. So even inside the center, we can collaborate. A very nice collaboration can be achieved. And of course, the objective of this R&D center is not only enhancement the collaboration inside the University of Tsukuba, but also we want to promote organization, large-scale industrial academy joint research, including the private companies, overseas organizations, and of course the national industry, national organizations like NIMS, KKI, and such national institute in Tsukuba. Because our goal is the same of carbon neutrality, and we are the expert of the materials, so we want to contribute by the collaboration. And we consider what is the effective method to accelerate carbon neutrality. Then we think about some schemes. This is just an example of the scheme. Recently, the many companies started to think about the carbon neutrality, but they don't know what is the best target for their company. the company, of course, has the seeds. So it's good to match the needs of society. But sometimes they don't know the needs. So, but there are many experts of the materials know the seeds of society. So we can make tailor-made joint research by conducting the lectures and workshop by the faculty members. Then we can set the target, and sometimes we go to the individual collaboration as classically conducted with researchers individually, or directly go to the feasibility study. Of course, in individual collaboration, firstly, we may make some new materials, and then we have to go to the test to feasibility study. So as a feasibility study, University of Tsukuba can offer the campus as a field of the experiment. There are many many collaboration schemes. So we are very looking for the partners, companies for such collaboration. That is the biggest objective of our R&D center. So I want to finally more specific our seeds, our technology, what we are tackling about these technology. Because of the time limitation, I just part of the utilization of hydrogen. This technology I want to introduce here. The hydrogen technology, we first need to make hydrogen. We have to store the hydrogen and convey the hydrogen safely, and then we have to use the hydrogen very efficiently to get to the electricity. So what is the key part? Key is actually one of the key element, key factors, the materials. Okay. In the case of hydrogen production, we can make hydrogen by water electricity. It's very simple, but a very promising method. Using the solar cell power, we can get the fuels. But now this conversion needs the electrode catalyst that is composed by very expensive materials like rare earth metals. So all over the world, if everyone wants to use this technology, we have to replace this expensive material to the very cheap, abundant material. So that is a material scientist's field. Also, hydrogen storage. We have to safely keep hydrogen with very light material, and high density is required. So materials is still required. And finally, the fuel cell. Again, now platinum, very high expensive material is used. So we need to replace the very cheap one. And our center professors did this contribution by creating materials. Just two examples I want to introduce. One is the fuel cell platinum substitute material, very cheap carbon material. Platinum is very expensive. This is kind of jewel, So we want to replace this one. Even now, platinum is used in fuel cell car. Even Toyota Mirai also platinum cobalt is used. Very large amount of platinum is used. And nitrogen doped carbon, this is very cheap material. That is the best candidate, one of the best candidates. All over the world to compete this material development. But there are huge controversial in the world about the important species. This is nitrogen, 2 coordinate. This is nitrogen, 3 coordinate. Which is important, no one knows. And very large controversial was before our work. We have clarified 2 coordinate materials are important by fundamental model catalyst study. So with increasing this number, we can increase linearly the current. This is very clear evidence. That's why this paper is cited over the 3,000 now. And from 2016, according to Web of Science, if you search the catalyst, 270,000 papers are matched. And if you sort as a function of the citation, the number 1 is our material as a research article. So this surely accelerates the development of the alternative material. The last material I want to share here is the hydrogen boride. This is what we made. This is how to make. It's very simple. The commercially available magnesium diboride we can purchase, and commercially available ion exchange resin, just mixing in acetonitrile. Then we can replace this magnesium to proton to make this HB. And this magnesium is stored here so that we can separate this. And it is a product. This is very light element, only hydrogen and boron and solid. And now, because this charge problems, that we call it as hydrogen boride rather than boron hydride. We cannot write this BH. We have to write this HB because hydrogen is not hydride but protonic. So this is a new material. No one calls such name. So we name this material because this is a new material. And up to now, we have published many interesting properties about this material, including catalyst, sensors, and hydrogen release store property, and recently CO2 conversion by this material. And also this is very stable for water. So this is one of the promising. And overseas, other groups also predicted this is nice material as battery material or hydrogen storage material. This is almost a champion data predicted by theory. So we are now trying to realize by our experiment. And because of the time limitation, I don't go into detail of other topics. So this is over my talk. Thank you very much.
Thank you very much, Dr. Kondo. So now we have the next speaker, Dr. Tai Yutaka.
Okay, thank you very much for a kind introduction. My name is Yutaka Tai, counselor of planning headquarters of AIST. First of all, I'd like to thank the organizers for giving me the chance for the presentation. Today, I will introduce some of our R&D activities that are contributing to the Japan's green growth strategy. As you may know, in October 2020, former Prime Minister Suga declared Japan's intention to become carbon neutral by 2050. In light of this announcement, the Ministry of Economy, Trade and Industry, METI, Keizai Sangyosho, formulate the green growth strategy through achieving carbon neutrality. The green growth strategy is an industrial policy which aims to create a positive cycle of economic growth and environmental protection, and together with the business community. The aim is to set ambitious goals and fully support the private sector's effort toward the carbon neutrality. Reaching carbon neutrality by 2050 means radically changing our energy consumption. In 2018, Japan emitted around 1 billion tons of CO2. And by 2050, this figure must be reduced to net zero by dramatically reducing our CO2 emissions and offsetting the remaining emissions through the carbon capture. In addition to the continuous technological development in energy efficiency for achieving the reduction of energy consumption, AIST is contributing to the green growth strategy by promoting the technological innovation in relevant research areas. In order to achieve the carbon neutrality, integration of various technology is essential. To promote this, AISD set up two open innovation platforms. The first is the Fukushima Renewable Energy Institute, or FREA. At FREA, we conduct demonstration and standardization research on photovoltaics, wind power, and geothermal, and hydrogen energy carrier applications. You can see some of the experimental facilities here on the photovoltaics and wind turbine. The other one is the Global Zero Emissions Center. This is not the one in the Tsukuba University, but this is in Tsukuba Center. But we conduct fundamental research in the site for the renewable energy and the carbon reduction technology and negative emission technologies. Let me introduce one of our distinctive technological development, that is the artificial photosynthesis. This technology mimics the mechanism by which plants convert solar energy. Depending on the feedstock, hydrogen and the useful chemicals can be produced simultaneously. We have a long history of research in this field and have developed the world's first system of its kind that responds to the visual light in the solar radiation. Today, with the use of bismuth-based photocatalyst, the technology has advanced to the point where it equates to the natural plant in terms of the energy efficiency. But still, the efficiency is very low. So to further boost the efficiency, improving the performance of the photocatalyst is key. The R&D of a photocatalyst involves an enormous number of sample investigations, so it takes much time. So we have developed a robotic system that automates the entire process from the catalyst preparation to the performance evaluation. By machine learning the collected data, we succeeded in taking the catalyst such speed to the next level compared to the conventional methods. So, and in future, we will continue to develop the system that expected to be industrially profitable for social implementation. Global collaboration is essential to realizing a sustainable society. As part of our international activities, every October we host RD20. RD20 is a global conference focusing on clean energy technologies for facilitating the realization of decarbonized society and creating the necessary environment for the international joint research. So this conference was instituted at the Davos meeting in 2019 under the Japanese government's initiative. The first conference was held in Tokyo in 2019, and followed by the two successive annual conferences. But due to the COVID-19 pandemic, the last two conferences were held online. And this year, we will hold the leaders meeting of this RD20 conference on the 6th of October. So if you are interested in this conference, please register from the RD20 homepage. And you can watch the meeting through the live streaming. AIST concluded a comprehensive MOU with 8 research institutes from RD20 members. We have conducted totally 40 international collaborations since the first RD20 conference. Areas of research include hydrogen and thermoelectric devices, power electronics, battery and solar cells, and others. And lastly, AIST is working closely with the domestic and international partners to assist Japan's implementation of the green growth strategy and achieving the carbon neutrality by 2050. And this is the end of my talk. Thank you very much.
Thank you very much, Dr. Tai. So I would like to invite the next speaker, Dr. Tsuchimoto Takahiro. Ready?
I'm Tsuchimoto from BRI, Building Research Institute. I represent our R&D project for energy efficiency standards and the implementation of the mid and high-rise timber construction. So, at present, it is Japan's policy to strengthen measures against global warming in order to achieve the carbon neutrality by 2050. Oh. This is our institute. My laboratory is here. On the other hand, looking at the situation in the housing and building fields, 30% of energy consumption is in the building field, and it is necessary to accelerate energy efficiency measures. Looking at timber, that is fixed to carbon. The building field accounts for about 40% of the demand for timber, and it is necessary to promote the use of wood in the building field. In response to this situation, the government policy stipulates expansion of the scope of the obligation to comply with energy efficiency standards and promotion of the use of wood. Building energy efficiency standards have always been standards for effort targets. Since 2008, standards to be observed by housing business builders who supply a certain number of housing units or more every year have been established. And since then, energy efficiency standards have been gradually strengthened. The Building Research Institute also began research on energy efficiency in 2001. And the results of this research have been gradually reflected in the building energy efficiency standards of the time. Since 2013, the BRI has published a web program of energy efficiency standards to make it easier for construction companies to calculate energy efficiency. The flow of social implementation of the research results of BRI on energy efficiency standard has been summarized. In response to the request for the sophistication of energy efficiency measures, the BRI has been asked to reflect new technologies developed by private business in energy efficiency programs. We are continually engaged in research and development related to performance evaluation. In addition, the national government is moving to expand the number of housing and buildings subject to the obligation to conform the energy efficiency standards. BRI is also working on the development of simple energy efficiency calculation methods to be able to respond to these needs. These results are reflected in national technology standards, and social implementation is progressing by utilizing them by private companies and local governments. Next, I'll explain the high-rise timber construction. Well, this is the background. Oh. Non-residential building is not wooden. Residential and low-rise, first story or second story only, is wooden, but mid-rise and high-rise is low level with the timber construction. So the mid and high-rise timber construction is very low. In order to raise the carbon storage in the field of building, it is effective for the mid and high-rise timber construction to increase. The limitation of the stories and the height of timber construction has been cancelled on the revision of the building standard law at 2000. However, Japanese constructors don't have experience to build mid and high-rise timber construction. So we conducted R&P project on mid and high-rise timber construction. It is difficult for designers to grasp the collapse behavior and design the ultimate capacity of timber construction, which is required for all kinds of construction in building standard law of Japan. Types of building construction is various. This one is this one. No castle. Right side below is Japanese traditional post and beam construction. Is aimed to the glue structure with braces. Left side below is 2x4 construction. 2x4 needs origin. 2x4's origin is North American housing construction. Representative of the mid and high-rise construction is mass timber. For example, COT. Mass timber includes the COT elbow and GOT panel. GOT is glued laminated timber. COT is cross-laminated timber. And one unique construction method is using the wood-based glued composite panels. Today, I'll explain the two-way mass timber and wood-based glued composite panels development procedure. At first, I'll explain the mass timber. We considered the effective joint method. One is a sleeve tube joint. This is adopted to the mass timber construction. This merit is the sleeve tube joint can resist the compression and tensile and shear force. So we tested the various under various forces. We obtained the load displacement curves. The structure was modelized as shown here, left side upper. This model is constructed by the elements and the spring. Spring includes the load deformation curve of joint. And analytical model is constructed by the model. So we conducted the pushover analysis. We obtained the load deformation curves. So we confirmed the totally collapse behavior at approximately same time. Yeah, it's very difficult to explain. So finally, under rarely occurring earthquake, the story processing capacity satisfies the demand capacity in each story. And under extremely rarely occurring earthquake, the story processing ultimate capacity satisfies the demand capacity in each story. Of course, it was confirmed that elements and joints prevented the advancing failure. So the results are here. Left side is elevation. Right side is a layout of structural members. Small wall, it's a COT. Very many COTs used in here. This is low figure indicates the standard floor plan. Okay. Next, I'll explain the developing procedure of the 10-story residential construction with composite material of wood-based glued composite panels and glue lamp. So there is a unique point is the composite materials of wood-based glued composite panels and structural glue lamp constructs a two-way rigid frame by use of large steel connector. So we verify the addition rule for wood glued composite panel and glue lamp, and parametric study on the number of the layout of glued jointing rods. So next procedure is approximately the same of the mass timber. So we confirmed the safety of the rarely occurring earthquake and extremely rarely occurring earthquake. So results are here. Elevation. Left side the elevation. Right side the layout of the structural members. Small square is the steel connector. So conclusions. In 2020, model structural design for 10-story disaster recovering house complex using mass timber and mass timber construction, construction with composite materials of wood-based glued composite panels and glue lamp. The detailed design of them were completed in fiscal year 2021 after the review for fire resisting durability and floor sound performance. Model primary structural design completed for 10-story brace structure and 8-story glue structure with sheathing panels modified 2x4. After the studies on the optimized layout of structural elements, the safety of each part and the fracture behavior and so on. So the model structure design will be completed at the this year, end of this year. Thank you for your attention.
Thank you very much, Dr. Tsuchimoto. And then we have the final speaker, Dr. Ashina Shuichi. Is that okay? We wait for this.
Yeah, okay, thank you for our introduction. And this is Shuichi Ashina from NIES, National Institute for Environmental Studies. First of all, I'd like the organizers to giving me the opportunity to share our recent activities related to the decarbonized society research work. Okay, here is my slides. And this is the historical trends of the gas emissions in Japan, and you can this is 100 years data, and you can see we are still far from the decarbonized society. Even GHG and the CO2 emissions are downward trend after peaking in the 2030. So that we need to more accelerate or promote the actions to the decarbonized society. And also the decarbonized society needs the drastic transformation or drastic shift of all the social systems. Here's an example in the energy system. Actually, this is the result of our colleague AIM project in NIS, and you can see in order to achieve the decarbonized society, we need to shift our energy system from the fossil fuels to renewable energy, as you can see here. This is the national scenario, and also in order to achieve or in order to accelerate the decarbonized society actions to the decarbonized society, we need to incorporate or gain the cooperation of a wide range of stakeholders. Of course, the scientists is around, and policymakers is also, and the international aid agencies, private companies, local communities, and NGOs. But in many cases, national scenarios, as shown just last slide, are the solutions for somebody that wants that. Okay, national scenario, we understand it, but that's not for me. It's an unusual case. So that's where now, so I mean science and the research expect to establish methodologies and deliver actions and roadmap effect for the daily lives and the businesses. So that's where now focusing the local scale decarbonized society. And here is our approach, NIS approach to the designed local actions. We are working, or we are developing the three different, but mutually interrelated methodologies for the designing the local decarbonization actions. First one is the macro design of the city. We focus on the entire city or whole city, like whole Tsukuba city or whole the Tokyo area or some other things. And the second one is the spatial design. It's related to the land use. It's related to the land use zoning or network design and local energy network, also including this stage. And this is also related to SDGs 11, sustainable cities and the communities. And the final one, most small scale, is the project design. It's a core project for the smart city, and it's focused on the more somehow detailed design of the city blocks or some of the things. And this is maybe related to the super city concepts here in Tsukuba City. So later, from now on, I would like to share our activities one by one. So first, here is a macro design of the city, and actually this is a preliminary study. Here, as you can see, the bottom side picture is an example of a preliminary study in the Tsukuba City's case. Assuming all municipalities take the decarbonization measures set in the national scenario, so that we find that more than 90% of municipalities will achieve CO2 reduction over 90% from 2030, not the 100%. No municipality can achieve the zero net emissions by taking the national scenarios. Here is an example, and the Tsukuba City will reduce CO2 emission by 6%, not zero. By 2030 level, and reduction by measure the 90% of demand reduction and the 30% for combustion and efficiency improvement, and the 38% for the renewable energy and grid electricity. So that's here in Tsukuba, the most effective action is installation of the renewable energy and expecting to the decarbonization and the grid electricity. So that is the first one. And the second one is the spatial design. And here is really so that's maybe a little bit difficult to explain, but we assume the several types of future spatial scenarios. First one is the BAU, just same as else. And we assume that next we assume the compact city, like shrinking the whole cities. Whole cities, and the final one plus green growth. And we find that by shrinking the city, as a compact city, and taking the green growth strategy, so then we find that 50% of CO2 can be reduced. So that would be the only the thinking, the changing the land use patterns or land use strategy. So that's the land use is a very important aspect to thinking about the local decarbonization. And the final one, here is the project's design. Actually, this is not the Tsukuba City ones, and our activity, NIS joined the Sustainable Rebuilding Project's Shinchi-town of Fukushima Prefecture. Shinchi-town is located the most northern part of the Fukushima Prefecture and the devastated area of tsunami. And we joined the project and discuss municipalities, officers, and private companies, and gas companies, and so on. Then we established some future picture or future design for the newly rebuilding area like this. And actually, this is still ongoing, but we successfully reached to the established local energy center in Shinchi. Yeah, in Shinchi, since Smart Energy Corporation has been established in February 2018, and by collaborating with Shinchi Town and seven private companies and banks. And this corporation supplies electricity and heat to the surrounding of the Shinchi station. So that now the system is working. Hopefully, this is the first stage to become the decarbonized region in Fukushima Prefecture. That is our expectation. And last one is energy saving project in the Tsukuba headquarters of NIS. Of course, we are scientists, we are researchers, so that's we should contribute to the society through research work, but we also contribute to the society to our own energy saving or our own decarbonization. But before that, we need to understand how energy is used here in NIS. So that NIS running its energy saving projects with participation of researchers and the staff in the facility management office and the planning division as shown here. And now the project collects detailed electricity consumption data and analyze the relationship between the electricity consumption and the research activities. And as you can see in the top of figure, we find the experiments in chambers or the running big testing facilities. Consuming the electricity, so peaking, right peaking type. And the second figure, we find that the stationary consumption by constant temperature and humidity rooms with supplying fresh air. So that's in order to reduce the electricity consumption in this building. Actually, this is a building scale. We need to review or define the setting of the stationary constant temperature and humidity rooms. And the last one is this is not understanding, but also the finding the impact. Yeah, in some facilities, the researchers voluntarily changes operation of lab equipment or stop unused machines. So that's we find that we can reduce electricity in such amount. So anyhow, this is the first stage. So next stage in the future, we will find a more effective design, effective actions to reduce electricity saving, electricity consumption, and the decarbonization here in these. And the last slide, I'd like to share our future perspectives. First is the promotion of formulating local actions in municipalities. But municipalities face a lot of difficulties, so that we will serve this various types of data and the feasibility of net zero, or the design of net zero energy system, and the interregional transmission of renewables, and the stakeholder engagement. Anyhow, we're well served. We will find, or we will prepare this kind of data to accelerate the formulation by local action, the local policies in municipalities. And the final one is already mentioned in Dr. Shakti. When it's considered the city planning with climate change risk management. So, and showing the several slides, but these are only focused on the climate change or the climate change mitigation. But we are now facing a lot of the floods, landslide, and also in Fukushima Prefecture, they affected by the tsunami. So that's we need to change our idea, city planning may adjust with consideration for regional climate change risk. So that in that case, we need to think about taking risks or avoid risk. That will be the next stage. But anyhow, this is another future perspectives of our activities. So thank you very much for your kind attention.
Thank you very much, Dr. Ashina. So we have six presentation by each institute. And as you can see that there is a talk from the rather science side and rather from the society side. But realization of a decarbonized society is not at all an easy target. So I think we have to think what we can do from the very many different views. And I think I think the combination or collaboration with these six institutes would lead to a very nice result. So we have in the next part, we're going to have panel discussions. We can expect many. I hope that there will be many active discussions in this part. So we're going to have break from now, and please reconvene here at 3:25. The next part will start at 3:25, almost 12 minutes later. Thank you very much. So we have, sorry. So we have everybody back here. Okay, so I would like to restart this session, Tsukuba conference session, promoting a decarbonized society. And before the panel discussion, I would like to invite Dr. Nagata Kyosuke, the president of University of Tsukuba, and he's also chair of the Tsukuba Conference Committee. And so we have a greeting from him. Please, Dr. Nagata.
Okay, thank you very much for your introduction. I'm Gyo Nagata, the president of University of Tsukuba. It is my great pleasure to make the opening. I'm sorry, I have been in Uzbekistan rector conferences, so that I'm sorry, but this is opening remark for the Tsukuba conference session in the TGSW2022. 3 years ago, we newly launched the Tsukuba Conference 2019, which shares a common concept with the TGSW. In TGSW, we discussed research and its contribution to the society, mainly with our university partners. While Tsukuba Conference with the main subject, science and society, provide a platform where not only our university partners, but also our young entrepreneurs or young researchers whom we call future shapers, beyond all borders, discuss social needs and the research to meet them. Approximately 1,500 participants from 250 institutions across 61 countries engaged in a truly international and interdisciplinary discussion through which we express their respective vision for the future and met their potential collaborators. At the first Tsukuba conference, 8 sessions were organized by research institutions located inside of Tsukuba Science City. At TGSW 2020 and the following year, a follow-up session was organized where 6 institutions reported the progress after the conference and discussed the future development in view of the impact of COVID-19, which had already been close to the world. Last year, the second Tsukuba conference was held, fortunately online because of the COVID-19 pandemic. As the development promoted by global society was confronted by serious challenges, including disparities and division enhanced by COVID-19 pandemic, we gathered young wisdom from various fields to discuss the solution and as a main theme of inclusive innovation for the new normal. The theme of the third Tsukuba conference to be held next year is Design the Future, a curiosity-driven quest for global solutions. The conference will bring together the power generated by the curiosity of young researchers to envision a new future for achieving the SDGs, for example, and the realization of the decarbonized society, an urgent global challenge. At the Tsukuba conference session of the TGSW 2022, so this one, the panelists from 6 research institutions in the Tsukuba Science City discussed issues related to the theme of next year's Tsukuba conference from a variety of the perspectives. I would like to thank the panelists for understanding the concept of this session and for participating in this session. I hope that the session is going to be fruitful and will give important suggestions to the Tsukuba Conference 2023, which will be held from September 26 to 28 and same place. Okay, thank you very much. Enjoy the discussion.
Thank you very much, Dr. Nagata, for very warm greeting to this session. So now we'd like to start the panel discussion now. So before we start, I'd like to show you this. Ah. Okay, so let me read again. This Tsukuba conference session theme is promoting a decarbonized society, zero emission challenge against climate change from basic science to social implementation in Tsukuba Science City. And as you can hear, as you can see, so in the first part, we have very different, we have many, what can I say, we have presentation from 6 different institutions from different point of view. So that's why we have this title, from the climate change from basic science to social implementation. I think there are 3, to me, there are 3 institutions which are rather in the science side to solve this issue, and 3 institutions are rather in the society side to solve this situation, this issue. So I think in the panel discussion, we can hear the comments and discussion from proposal from the 2 different sides. And I hope that is why we can say that we have this session in Tsukuba Science City. Okay, so we have some questions. As you can see, the 2 questions are: what kind of science and technology are required to realize a decarbonized society? And what are the issues and possible breakthroughs at each stage from basic science to application and social implementation? This is a very big question, big question. So I would like to to break down this question to more more specialized question. Regarding the reduction, first question is, regarding the reduction of CO2 emission, what are the issues and possible breakthroughs in 1, development of renewable energies, or 2, achieving a higher efficiency in generation and utilization of energies, 3, building a social structure to enable high energy efficiency. So let's start this more rather science side, but I think there are, in the last presentations, we have some results by the institutions. So may I start? Is there any icebreaker now? What are materials? There is any issues that, although you know this material is very important to solve the problem, but there is big breakthrough. We need a big breakthrough. Is that there? Is there such a material? Or is there any special analysis method we have to have, or anything?
Maybe I should be an icebreaker.
Oh, sure.
Yeah, I'm not a native speaker, so I try to use some figures. Yes, as I said, I just would like to make some comments. You know, in the material science, in terms of material science, there is a 2 approach. First one is a magic, I said. It's like a mimicking the photosynthesis. And during, its magic is very important, difficult. So during the meantime, I should improve more realistic approach. like improve efficiency. And I mentioned some example. And I just would like to give another aspect. If we found a very good material, it's okay to write the papers. But in reality, we have to dig from that material from somewhere. It's a picture of the lithium mining sites. So do we know the reality of the mining sites? So we have to know the mining site, and also we have to know how to manufacture it. And then it's a material science. But in reality, people must use that new material. What's the incentive? Money or moral or system? So of course, I'm a researcher in material science, so I try to find a new and write a paper. But reality, how many people can use this new material? So I don't know, but this another point is life cycle assessment of material or process must be very good, very important, I think.
Thank you. Is there any comment for this? Dr. Kondo.
Yeah, maybe the good example is the development of substitutional materials for rare earth or expensive but high performance parts like platinum. Platinum is now used for many important electrode for fuel cells, but the number of the platinum in the world is limited. So we are already facing the problems. We cannot continue to use the platinum if we want to develop the fuel cell. So we really have to make the materials. And as pointed out, if we make new materials, the process and everything we have to develop, of course. But if we use already established structures, just we replace the material, platinum to cheap carbon. That is maybe possible. So of course, carbon manufacturing technology we have to develop. But the important point is, material science have to seriously think about this situation. And I think that now most of the fundamental scientists not so seriously think about the situation. So if we recognize the problems, maybe many clever scientists can contribute more and accelerate for example, substitute the platinum to more cheap and abundant material so that everyone can accelerate to realize the carbon neutrality.
Yeah, thank you. Yes, I myself is a material scientist, and I think the possibility of material is infinite, maybe, and only we don't know how to make it. We haven't found out the new material, which might be somewhere. And that point is that yes, replacement, substitution of the expensive material, or the material which is the mine of the resource is in we'll say disputed areas. I mean, in places which are not as stable. I mean, it's not safe or whatever, and that's a main barrier or hindrance, I would say, to develop materials. And but it's a long way, right? And the goal, we have to be in the goal, the decarbonized society as soon as possible, probably, because now to this year, only for this year, we have very climate change, very unusual disasters like typhoons and high temperatures and heavy rainfall. So I think there will not be a long time to. So is there any yes, we have to keep on research work. But is there any other idea for, what can I say, implement the materials which is not very good, but so good into society? Have you ever, do you have any idea for this? Or, for example, society side institute,
Okay.
Okay, thank you.
That's a very important point. Well, we are targeting carbon neutrality in 2050, but in the meantime, our intermediate target is 46% of carbon reduction in 2030. 2030 is just around the corner. So we have to pay attention to the two aspects. One is the long-term aspect, and we will continue to develop renewable energy and so forth. But to the target of the 2030, we have to be practical. So we need to use some amount of fossil fuel in 2030, using blue hydrogen, not the green hydrogen. So we have to soft land our society to the 2030 and the 2050. I think that there are two aspects of research. So one is the a magic one and the practical one.
Thank you. Yes, Dr. Ashina.
Okay, I draw back to the comments to the Dr. Kimura, first one. I fully agree with the importance of the life cycle assessment. Yeah, in renewable energy, maybe during the use or during the generation, we have no emission. But if such technology emits many CO2 during the production stage or wasting stage, that might be not a sustainable energy system. So that's and also this is the same for the hydrogen. Yeah, we can get the hydrogen various types, and as Dr. Ta mentions that we have several types of sources, like green hydrogen, yellow hydrogen, or some other ones. But anyhow, in the future, as a magic, I say, we need to seek a way to generate the green hydrogen, but during the 2030 or some other things. We use blue hydrogen or some other thing. But anyhow, we need to think about a life cycle view. Otherwise, it's not sustainable. So that's I fully agree with the comments of the Dr. Kimura. Thank you.
Thank you very much. So we have the idea of balanced, what can I say? Balanced way of research to think many things. Not just to develop materials, which is very efficient and which is very useful, but we have to rethink what do we have to make? I mean, what we have to make up. Okay, thank you very much. Are there any comments for this? For example, what about social implementation to the materials? It's a long way, or is there any possibility that the magic suddenly magic comes? Okay, so let's skip to the next session. So we will come back to the science. I think this is a big issue, and at least three institutes are very common in this subject. So may I skip? May I go to the next question? Yeah. The screen. Ah, sorry, take time. Oh. So this question is about what we have done just now. The next question is regarding, oh, sorry. Okay. What is the background of the movement to decarbonize society and what issues we are facing? One, how far have we clarified the mechanism of the local warming in terms of future prediction? What is the current status of climate change? Two, natural disasters induced by the climate change and their impact on society. Three, what kind of society disaster religion and how can we build it? The question I make this is that we have to know, we have to, in the science side, we have to make research for new materials or new method or whatever to realize the decarbonized society. But probably you have to go back to the source, I mean the reason why we have to seek for the decarbonized society. And probably you have to learn what is the real situation of the, for example, global warming or the risk that we are facing now. Oh, so.
It's very.
Yes, please.
Thank you very much. So, yeah, we have already observed that the global warming over the last several decades. So the future temperature and precipitations also is expected to increase due to climate change over this century. So, and also based on the climate models and based on the many historical data, so it is expected that the frequency of floods and the extreme rainfall will be increased in coming days. This is the scenario at this moment. So so the main things is that the various types of predictions are available at global scales. So which one is very best and how uncertainty they have in the predictions. So it's really difficult to understand at this moment. So in this scenario, the scientific community are trying to understand more detail about the future predictions and their impact on weather related issue on global scale rather than local scales. So in my opinion, we should understand the uncertainty on using of global predictions model in local scale as well. So I hope further research may provide the additional information. So if we talk about what is the situations of the climate change at this time, so it's very much difficult to say what exactly it's affecting in community and in social scale or in global scale. So, but everyone understands that it's changing. So we have to adopt, and we have to do something very effectively. That's the one important point. So what I want to say that so if it would be very good if we have a better predictions, smarter preventions, and faster restoration to protect lives and livelihoods for the sustainable future. So this is the summary in these cases. But we have to do more research on the scenario, climate change scenario. This is my one of the conclusions.
Thank you. Yes, as you pointed out that although it is a global issue, but the disaster occurs in local area. Not like a big earthquake that involves the whole Japan. Before the typhoons or the heavy rainfall, it's not the local area only suffers. So,
Just want to have
yeah, right. Do you have any comment for that?
recent scenario, Japan. So if we look like a recent 10 years in Japan, So the extreme rainfall and associated flooding have been increasing. So every year we have experienced this flooding in everywhere. So in some case, it's very much local. So in some case, it's very interesting that we have in Japan, in city area, we have a very in everywhere, every rivers, there is very good embankments. So sometimes sudden burst of embankment is one of the issue. So how to manage, how to predict this kind of embankment failure, so that we can predict the flood inundations around the local area. So this is also one of the challenge. So we have to do consider this kind of small component or small things in a whole prediction systems. So this is my.
I see. Okay.
Yeah. Yes. As to the disaster, everyone, if something occurs, everyone said carbon dioxide is wrong. Carbon dioxide is wrong. But I think there's other factors like a deforestation or how to make a road or something. So in your field, a lot of research. So I would like you to let us know what's the real reason or real issue to be discussed. Otherwise everything is wrong. Everything was caused by carbon dioxide. So it's make us a wrong directions. We are laughing, but when I ask my boy or my girl, my wife, they say, so please let us know the real factors based on your research.
Thank you. One question with this topic from me, that is, do we really understand the global warming now? The function, the cause, mechanisms, and data? Yes, please.
Yeah, so I made some comments to Dr. Shakti, and as for the cause or the results or some other things, but anyhow, this question on the current status of climate change, we see the reports by the IPCC. Yeah, it's related to the working group one, and they already released really thick, huge volume of reports, and then concluded that it is unequivocal that human influence has warmed the atmosphere, ocean, and land. That is the current conclusion. So that's of course, as Dr. Kimura mentioned, that all the disasters are not caused by the global warming, but some are also, or the level is increasing by the global warming. Because the climate is already changing and varying, so that's every disaster is not directly related to the climate change, but the climate change we are now facing is accelerate at the level or the degree of the disasters or the impact to the society, also our health itself. Thank you.
Thank you. Yes, probably we know the present situations and what we have to do. Is that correct for everybody? Okay. So I think we don't have much time, so any comment?
To mention one point on the what kind of society is disaster resilient and how can we build it? This is also very much important questions, I think. And of course, disaster resilience is a part of broader concept, I think, and in terms of resilience. So of course, I think many of you know that the according to the Hyogo framework of actions, the disaster resilience is determined by the degree to which individual, community, and public and private organization are capable of organizing themselves and to learn from the past events. and and then they have to learn from the past and reduce their risks for future ones. So this is the one of the concept. So in that case, we have to give some priorities, I think. So the priorities should be so the understanding of disaster risks, and the second number may be strengthening the disaster risk governments, and another third point is could be investing in the risk reductions. So, and other number, the important could be the enhancing disaster preparedness for collective response and to building back better to recovery. So this is one of the important priorities that we should consider, I think, to for the disaster resilience. This is my just comment.
Okay, thank you, Dr. Park. So let's go on to next question. Sorry, click on. Yes, that's what we have. Yes, what we just discussed. The next question is, nice. Are there any social relations and technical evaluation necessary to realize a decarbonized society? One, the role of local societies. Two, is it possible to remove the abstracts to realize a decarbonized society and improve the present situation by arranging social regulation? Three, evaluation, standardization of the techniques required for realization of a decarbonized society. This question is rather, again, the social side of the aspect. But probably for the research work, there is some regulations or rules that you have to obey, and you can do what you want to do. So from such a small topics to the more larger, if you want to implement some techniques to the society, but you can't because of this, regulations or standards or whatever. Is there any comments for this issue? Questions? It's a bit, yes, please. Ashina. Dr. Tai, please.
Thank you. First of all, I want to put stress on social regulation and also finance. Generally, new technologies are expensive, so we cannot disseminate new technologies only by economic activity or economic rationality. So that is why the greenhouse tax and the EU taxonomy are paid great attention to. In a technical aspect, evaluation methods and standardization are critical for disseminating new technologies. In AIST, we founded a standardization office 2 years ago to promote strategic standardization. It's very difficult, so we are just beginning even now. But in fact, AIST is involved in 14% of new proposal of standardization from Japan. So we will make effort further in standardization. And I also put stress on the LCA. The nowadays financiers are looking at the companies in terms of how eager they are targeting carbon neutrality. That is one of their evaluation point for investment. So from the company side, they want to get a precise LCA method and the precise and the fair LCA method. The cultivation of LCA method is also very important topic. Thank you.
Dr. Ashina, please.
Okay, thank you. First of all, I don't want to say that adding the regulations to to achieve the decarbonized society. Yeah, we can set the several types of regulation, like don't use electricity from coal-fired power plants, or don't use inefficient or some other thing. We can set that, but it's not a good way, I think. In Japan, 80% of the GHG emissions comes from the energy use. But when we see the energy use, we don't care about the cost of use of energy. For example, yeah, when we buy that, so somehow bags or the PCs or watches, we carefully check the cost, price beforehand. But when we use electricity, we don't check the cost. We don't check the price. We just check the bill. Oh, okay, yeah, this month, okay, we use this amount, and oh, we need to pay this money. Okay, that's all. We don't care the cost. So that's the important thing is to include the system to care the cost of the energy use. It's maybe the very important field of the technology, especially in the ICT. Yeah, recently many companies, private companies, or the researchers install the electricity monitoring system in the houses or the buildings. But maybe that's a good way. We can check how much electricity, how much energy now we're using, and how much does it cost. And such kind of system should be installed instead of regulate all the activities. So that's I suppose that would be my comments. Yeah, thank you very much.
Yes, Dr. Ashida-san get a good point, and I think incentive or motivation is very important to realize, So I have a question to Dr. Tai-san, and you said you evaluate and standardize of the techniques. So do you also evaluate how the technique is attractive for society, or how much incentive? Of course, money is very important, but sometimes, being carbon oxide free seems to be a kind of fashionable, such a kind of consciousness, a change of the feeling, maybe also another incentive. So my question is, do you have a system to evaluate such a kind of incentive force for each technique?
Oh, it's a very difficult question. Actually, we don't have such a system. We are developing a LCA technique just to fairly evaluate the how much carbon dioxide produced during the production of the product of a company. So that nowadays I feel that investors are very interested in that aspect. So that may be the incentive for the companies because whether or not they can get the investment depends on how much they are keen to the carbon neutrality. So the technologies that leads to the carbon neutrality. So, am I answering your question?
Yeah. This is a very tough question, but yeah, I understand. So it's a very good way to evaluate technology in many ways. Thank you.
Thank you for discussion. Yeah, yes, probably most of the panelists want to say many things about this, but can I move to the last question? This is the most important, I think, in this session, in a sense that may I? Sorry, I always go back to my. And this is a question with you just. Oh, sorry. This is a question we have. We just discussed. And the final question is not final two questions actually. What is expected for future progress in potential collaborations? Collaborations in 1, material development, 2, analysis, clarification principles, 3, reform of social structures. The question I put this is that because we have 6 institutes from the different fields with a different background and different targets, I think the collaboration is a key word for all the institution in Tsukuba, because we have 200 institutions in Tsukuba, and to me, there is not much collaboration between because of the different fields, different the targets or whatever. So this is, I think, good chance, good opportunity to seek for any collaboration we can do in the future. So any, for example, the material development or the comments or yes, please go, Dr. Kondo.
Yes. Collaboration in these, for example, members are actually very good idea. Today I learned the importance of the effect of visualization of the usage of electric power, for example, that Dr. Asina presented. That is very effective to know. Yeah, actually, in University of Tsukuba, we also monitor the daily usage of the electricity. But if we can collaborate with material development, for example, more feasible study, more accelerated feasible study may be possible. And what I thought up to today is more very classical way, just same as previous development of material science. So for example, lithium-ion battery, of course, 20 years ago, maybe not so effective one, but now it's a very effective one. So like that, it's developing. The materials are really important, but maybe we should think about the strategy more accelerating way. And one is the collaboration. That is what today I saw. I don't have a good idea for more specific idea, but maybe that.
Yeah, I know. Yeah. Okay, Doctor.
Yes, I completely agree Sensei's comments. Yes, I feel after talking with the many specialist talks by many specialists, and after discussion, I think I have two type of cooperation. One is a direct cooperation, like for example, battery. Exactly, he said. In terms of the, direct cooperation, maybe we can cooperate in scientific field or something. But I think there's another indirect cooperation. We have a different background, but sometimes approach is quite similar, like a multi-scale approach or handling the big data or AI technology. So I think that talking or sharing this kind of the background may be a very good, I think, and I hope. And another thing is the concepts or idea or strategy, tactics, even in a nanoscale or meta scale or, global scale, we try to use some kind of scientific approach. So definitely, I would like to share this kind of information, and this kind of cooperation will be fruitful for everybody, I think.
Thank you very much for this, very nice biograph. Okay, Dr. Takji.
I
Shakti?
just want to comment
Okay,
on
please.
Dr. Kimura's idea. Of course, yeah, I agree with his idea. And in Tsukuba, there are many research institutes, of course, and they have been conducting the exceptional innovations in varieties of fields. So we have varieties of data and varieties of results. So in some case, they may be useful for each other. Then why not to start some data sharing with, at least in Tsukuba Research Institute, so we can share data. And of course, the next step may be the working together in multidisciplinary subject as a pilot project. So we can select some subject and we can make our effort from the different directions, so that we can so the society could be benefited from this kind of activity. This is my comment.
Thank you, Dr. Shakti. Yes, I think this is a good chance for us to talk, to start talk, maybe start discussions, to make a point. Is there any? Okay, Doctor.
Yeah, I suppose that's the one possibility is to think about the Tsukuba city's decarbonization, because we are gathering in Tsukuba. So that I'm not sure that Tsukuba city can will or not, but it's one possibility. Yeah, if we want to decarbonize Tsukuba, so then we can do this. We can do this. I can do this. So then somebody corrects and discuss the impacts, or of course, it includes social science aspects also needs to be included. But anyhow, we have a research institution here, and this time we may miss some agricultural research institute or the other institutes. So, but if we can invite all the research institutes, then we can think more practical way to achieve the decarbonized Tsukuba. If we miss the finding the way the decarbonization in Tsukuba, maybe other cities than that. So that's one possibility. Thank you.
Thank you. Is there any attendees from city? Yeah, that's I think a strong slogan: decarbonize Tsukuba. The strong. Thank you very much.
Maybe we should talk to Meja Igarashi.
Okay, thank you very much for the talk. Okay, so now the last question is that I put it will be I leave it to the conclusion, because what do we accept for the future progress initiative to realize the decarbonized city society through the wisdom of the research institutions in Tsukuba Science City, and that's what we discuss now. So I will conclude that I will mention that in the conclusion. So there's some Q&A time now. Is there any questions from this conference hall? Any question? Okay, any question, Yes. Yes, there's a. Yes.
My name is Okabe NID. I have one question to Dr. Ashina-san. Thank you very much for showing a breakdown of emission decrease in Tsukuba City. I think it was very interesting, like 90% demand decrease, 30% efficiency improvement, and if I remember correct, 38% renewable energy. And my question is, if we consider in worldwide scale, considering a rapidly increasing population, I think 19% decrease of energy demand may be difficult. Maybe demand worldwide may increase. So am I right in thinking that worldwide scale globally, we need a higher target for energy efficiency improvement or shift toward renewable energy? Would you please comment or maybe explain about that? Thank you very much.
Please.
Okay, thank you for your question and the comments. And absolutely, in the global scale, energy demand will increase, especially in the Asian countries and African countries. So that, this time we only cared about the Japan's case, so that the demand slightly decrease. But actually, here in Tsukuba, the rate of reduction is not so big because the future population, the other social factors are not decreased so much. But if we see some rural areas, I don't want to say any special name, but they decrease population and maybe the quarter of the current from the current level or some other things. So that's in that area, maybe without taking any actions, CO2 emissions will reduce 75% or some other thing, but not a good way. So that's we are now finding the solution for achieving the decarbonization as well as keeping the local activities, level of the activities. For the Asia, for the global scale, especially for the Asian countries, actually we are now talking about the how to achieve the decarbonization in Asian countries. So actually that would be the starts from this year. So that's this time I have no idea for the future, but at least energy efficiency improvement and installation of renewables are both are the key actions even in Asian countries. And first one, I say the energy efficiency improvement. It's a really technology issue, so that might be the good contribution from the Japan's research institutes. Maybe especially in AISTs can lead such kind of contribution or the source of the technology development. Anyhow, that would be the, my short comments. Thank you very much.
Thank you. Good question, comment. Thank you very much. Is there any? Okay, please.
Hello, Peter Furi. I'm affiliated with ETH Zurich and Keio University. I think the big question about this decarbonization is just the scalability ultimately of all of these technologies. I was discussing earlier with Kimura Sensei, you know, the ecological footprint obviously of all these solar farms, wind farms. We know that, you know, it has a massive ecological effect. And right now solar, we're starting to get into the point where, you know, these panels have to start to be replaced, and you have leaching of heavy metals, etc., into the groundwater. So they come with their own host of issues. And of course, producing these technologies, you know, we just tend to think that the unicorn arrives, you know, without any impact, right? But production is still incredibly carbon intensive. We cannot produce steel sustainably without, you know, using coke. That's pretty obvious, right? Why isn't nuclear discussed at all today? What is the role of nuclear in all of this? If we want to look at sustainability, if we want to look at long-term sustainability and scalability, we have to somehow, you know, if we want to move towards electromobility, for instance, I'm a transportation planner myself, then somewhere we need to charge all of these vehicles. And there is simply not enough solar and wind capacity to do that. So we need energy-intensive sources. So where does nuclear fit into this? And I would like to hear the panel's response to that. Thank you.
Any comments or? Yes.
We're not working in nuclear energy, but you're right. The point is the energy density. I agree with you. So the renewable energy is very dispersed. So it is not very efficient energy. So I do not have any comments on the development of nuclear energy, but in the white paper of government says that the 30% of the energy will be the nuclear energy in 2050. So the nuclear energy is indispensable.
Okay. So one more question if we have. Okay. Okay, thank you very much. So before I conclude, make conclusions, please approach the presenters and panelists here for the nice discussion today. Thank you very much. Thank you very much. So now I would like to come back to the slides for conclusion, not conclusion, but the slides aren't. Sorry. Slide. Now. Now. Okay, so let's go back to the panel discussion. The first question was, oh, sorry, this is not, okay. The first question was about the science side and, okay. See, regard this material issues, or not conclusion, but we have a common understanding for making research, making new materials to solve this problem from the efficiency or low energy side, and we have to carry on this research, but we can't wait for the magic. So I think the key point is the collaboration to do as many things as we can do in a limited time. I think that's one conclusion that we had. Material is very important, but we need more idea to pursue more speedy, probably, research work. The second one is the background of this issue. Why we do have to think and do for the common society. And the common idea here is that, yes, we are facing the global warming. We have to do something. That's, I think, common understanding of the panelists and for all of us here, maybe. There's no, somebody might say that this is not real, but I think we think that, because we believe this, what can I say, the basic idea, we do the research work, we do what we can do, right? Okay, this is the next, second conclusion. And then for social regulation, evaluation, standardization things, there's lots of discussions that I can't say in a word, but probably new technology is very expensive, but there is an economical sense of the world. I mean the society. So we have to balance it. So in order to balance, probably we use cleverly the evaluation, standardization, or whatever to disseminate a new technique more easily to the society. I think then I think if we have good regulations to to realizing the decarbonized society. It is good. So probably we have to say from the researcher side, what kind of regulation we need or we want to do more to reach the target, to reach the goal more quickly or probably as soon as possible. So the second conclusion that these regulation and technical evaluation standards are necessary, but we have to think what is the best. That's that is the third conclusion. And final is that the collaborations. Yes, here the common idea is the collaboration is the key point. There's lots of institutes here in Japan, and here only in Tsukuba Science City we have lots of institutes, and probably, but from Japan to the world, the collaboration to, can I say, I forgot English. That to do what the other collaborator will do, what you cannot do, right? That's the basic idea of collaboration. And that's very very important here. And I want to, and the final question that what do we accept for future progress and initiative to realize decarbonized society through the Wisdom Research Institute in Tsukuba Science City? Yes, we will do, right? To decarbonize the Tsukuba City first, and gathering up the wisdom from the many research institute with a different background. That's a key point, probably. We have many meetings, academic meetings within that field, within a specific field, but not over the field, right? So I think that this was a very good opportunity to have to exchange the opinions and comments among the various fields. Okay, thank you very much. I would like to conclude this sessions. Thank you very much for listening and joining the session today. And thank you very much for the panelists again. I would like to conclude this session now. Thank you very much.